sectors, but if they are significant in your city, then you should definitely measure and report those emissions as well. So you've all got the slide deck and the handouts for today. It should be a fairly light session compared to the previous weeks because this is an optional sector, so we're not going to go into too much detail. Should hopefully be a bit easier to follow for most of you. As always, I'll do a quick recap of last week, the last session on Monday, and then we'll dive into Module F on IPPU and FOLU. So a quick recap from Monday. We looked at the waste sector. We looked at the different subsectors within waste, at solid waste disposal, landfill sites, at biological treatment, at incineration and open burning and wastewater. We understood how to treat biogenic carbon, and any carbon that is from a biogenic origin doesn't get totaled in your GPC, but you can report it separately. In fact, the GPC encourages you to do it, report it separately, whereas the CRF, the Common Reporting Framework, says this is optional. So in any case, you always report fossil carbon, but for biogenic carbon, it's optional. But always make sure if you do report it, you report it separately, so it doesn't get counted in your total emissions. And that is because biogenic carbon is seen as being part of a much shorter cycle during the growth phase before it gets burnt and then sequestered again. So there's no long-term release into the atmosphere in the way there is when you burn fossil carbon. So always treat biogenic carbon separately. And in the Cirrus tool, there is a separate column for biogenic carbon. So it'll always make sure that you do capture that and report it separately to fossil carbon. We then looked at the different treatment types in a bit more detail. And then we also discussed the issue of when to report emissions as energy or as waste. And the key thing here to think about is it waste or is it a resource? Does it have a use? If it has no further use, it's waste. If it has a further use, it becomes a resource. And if it's used for energy, either for generating heat or power, it becomes an energy source, and therefore it's captured under consumption of energy or combustion of energy, usually under stationary energy or transportation. So always think to yourself, is this like proper waste? Does it have no further use? Am I burning it just to get rid of it? Or am I burning it to generate power, in which case it does have another use, that of creating energy? So always think to yourself, is this waste or is it waste to energy? And if it has a further use, it's captured under a different sector because it becomes a resource and not just the end of the line waste. Same with recycling. Recycling has a further use, it becomes a resource. So recycling isn't captured in the waste sector because it becomes a resource, and the energy used in converting paper into cardboard or other materials is captured under industry and not within the waste sector. We then used the waste calculators in Cirrus, and we just touched upon the setup function in Cirrus, and then we moved on to the calculators. Next week, Monday, we'll go into Cirrus proper, so I'll take you through the whole tool in detail, a full demo, and I'll do a full exercise in Cirrus as well. But for now, we just looked at the calculators, and we tested out the 4 different calculators for waste, and hopefully you realize they're fairly easy to use and fairly user-friendly, where you've only got to really focus on those red boxes, make sure they're complete. And if you wanted to override any of the settings, you can by using the white boxes. And finally, we went into the practical, where we applied those different calculators, but we also looked at the scaling approach for national data. We then brought back the data we did in session 2, where we scaled the KL data to our in-city boundary, and then we compared the 3 different methodologies and the results they gave us to see what impact they had on the emissions total. So quick recap of the practical. So we had a few exercises. One was for you to discuss in groups the different types of waste and where does your waste go. And then we had the exercise. And then for the bit was also for you as homework exercise was to document table 3 and table 4 in your workbook, which is the GPC summary table and the action plan. Just focusing on the calculations, So we had two calculations. One was for, four calculations for the different waste types. We used different approaches. So we used the Cirrus calculators, and then we also used the proxy cities approach, which we've done before using Kuala Lumpur in session 2, and we used the scaling national data. Those are three methodologies you can use. The best is always using local data and local emission factors. And given that waste is often managed and controlled by a city authority, you should have fairly good data in that regard. So definitely do speak to your waste colleagues in terms of what data they have regarding how much is collected, where it goes, and what the disposal routes are. But failing that, you've now tried three different other approaches using a proxy city, using national data but scaling it down to your city boundary, and using those Cirrus calculators. So these are the four calculators we used in Cirrus. To scale national data, very simple calculation, which hopefully you're very familiar with by now. You get the national data multiplied by your scaling factor, and then you get your scaled activity data. And then finally, we'd used a proxy city, but we used that back in session 2, where we applied the scaling approach to Kuala Lumpur and based our population on theirs. So those are three different approaches, and they gave you three different results. And I shared with you my results, which showed that for most of them, they were actually in the same ballpark, which was encouraging. Still some differences between them, but close enough to think, okay, you know, my calculations are getting me in the right ballpark, and I can be confident that these are broadly right. There's one key difference, which is that biological treatment for Kuala Lumpur for using the proxy city data, where it was much higher for the proxy city approach than for the other two approaches, and that was I think we discussed probably because maybe KL has more advanced biological treatment facilities, and therefore it's able to treat more of its biological waste separately, which is why it might be higher. But that will be something when you've done these similar calculations to deep dive into that. It's actually, well, why is that different? So don't just say, oh, they're different, I'm not going to use the data, but ask yourself, well, why are those differences there before deciding which methodology to use. But important to know that different methodologies will give you different results. It doesn't make them wrong, and quite often the differences aren't that great, particularly if your emission source is fairly small. It doesn't have a huge impact on your inventory. So then simply go back to your principles and decide, well, what is most relevant? What is most appropriate for my city context, given our resources, our capacity, and how we're going to be using this data. So I just want to pause here and invite some further comments, reflections from yourself. And you know, if you were able to complete the exercise and you had those data points for using all three methodologies, what differences did you see, and what questions did you have sort of once you had those different numbers? So maybe just a few minutes for any reflections, any comments, or any questions on the waste exercise from Monday. I appreciate it early, and you're probably still warming up. I am keen to hear your feedback though, just to know how you're experiencing these calculations, the kind of questions you're having, the thoughts you're having when you're doing these calculations, when you're seeing the different results. So either speak up, use a chat box, or share your thoughts via deep or any questions you have. But it is important that you're aware that different methodologies yield different results. And we had the same when we looked at transportation. We looked at those 4 different ways of allocating emissions to a city. That will have a huge impact on your inventory, but it doesn't make the results wrong. It just makes them different. And it's important to understand why those differences occur. If the differences are small, ignore it. Then go with whichever is easiest. If there are big differences, just ask yourself, why are they different? Of course, double check your calculations to make sure you've done the calculations properly. But otherwise, just ask yourself, well, why are they different? Because in most cases, the differences between these 3 approaches weren't that crazy. It wasn't like, one was reporting 5, the other was reporting 5 million. They were all in a similar ballpark and similar types of numbers, either single-digit numbers or six-digit numbers. So that's encouraging. That should give you encouragement that you're in the right sort of space, and the emissions are going to be broadly right. Where you do see big differences, like we did for biological treatments, then definitely ask yourself what is going on that's making these results different. And often it could be that one city is indeed very different, and in this case, KL might have more advanced facilities that they can treat their waste separately, their organic waste separately, and therefore, actually, we might find the majority of biological treatment facilities are in KL, and therefore you would expect that to be much higher than scaling data or using a serious calculator. But if you do see differences, always ask yourself why are they different, and try to understand what is driving that difference. But also good to know here is if you're just doing this calculation using your own data, your own activity data, your own emission factors, which is great, just then run the same exercise using the serious calculators, using national data, just to see if you're in the right ballpark. So this is always very useful, just to double check and to validate validate your results. It's always useful to do a second methodology, just to make sure you're in the right ballpark and the figures are as they should be. There's a comment there in the chat box. Personally, I find insufficient local data and wrong/inconsistent data sources assumptions led to huge differences in all three methods. Yes, and that's the reality for you as an inventory compiler. You're never going to get perfect data, and you've got to weigh up what's more important, using local data, which may be incomplete, which might be you may need to make some assumptions to make that complete, or using a more complete approach, but that may be less accurate because it's more global or it's an international calculator. So that, I think in that comment, you've really sort of summed up the challenge you have as a compiler, is you've got to make decisions, and you've got to decide between data, between methodologies, and no one's going to tell you the right answer. And you're the person that people are going to be looking to provide that answer, but you don't have the right data. You're maybe unsure about your assumptions, and when you apply different methodologies, you get different results, and you don't know really where to go. So that is the big challenge you have as a inventory compiler. Definitely talk to your colleagues, talk to other people in the space, the network where we've got on this call, but also use your own judgment and your own expertise in deciding actually what is most relevant here for my city, and try to understand why there are such differences between methodologies. Is it the emission factor? Is it the data? Are they the assumptions? But yeah, this is the big challenge. It's the calculations often are the easy bits. The difficulty is in choosing the methodology and finding the right data. Another comment: so long we fix method and acknowledge our assumptions, our inventory should be fine, complete. That's correct. Yes, as long as you're transparent, as long as you're accountable for your methodology and you disclose your assumptions, that is the best you can do. Obviously, don't make stuff up, but do your best. Be very transparent around your assumptions, your methodologies, and that allows other people reading the inventory to say, actually, I think I've got better data, possibly, and they might share that with you. But the key thing is just document your approach, your assumptions, your methodologies, record them in your report, your inventory tool or report, so you're being fully transparent, and just acknowledge the data is incomplete, the data isn't perfect, and be open about the assumptions that you've made. But the key thing also here is just if you're unsure, then use different methodologies just to test things out. And even if you want to use a local approach, using local data, local emission factors, which again is always the preferred approach, then I would always recommend you find a simple calculator or you scale national data just to see, am I in the right ballpark? Are we talking about 1,000 tons here? Are we talking about 1 million tons here? Are we talking about 2 or 3 or 5 tons here? Am I in the right ballpark? Just double check that using another methodology. But yeah, I think don't worry about data being incomplete. That's not your responsibility. That's often just the reality. But do make sure you're always open and honest around your assumptions and methodologies. Okay, any further questions on the exercises from last time, or indeed from any of the previous sessions before we continue into IPPU and FOLU? Okay, so if there are no further questions, then let's move on to session number 6, which is today, focusing on IPPU and FOLU. So we're almost 3/4 through the webinar series. Okay, so today IPPU and FOLU. I'm going to give you a background on IPPU, and then we're going to dive into a simple practical exercise, and the same for FOLU, a bit of theory followed by practical exercise. And at the end, I'm going to touch on other Scope 3 emissions, very, very lightly, because it's a whole other topic, but just to give you some pointers for those who are interested about where to get further information on measuring other Scope 3 emissions. Okay, so let's deep dive into IPPU. So IPPU stands for Industrial Processes and Product Use, and it comes under Basic Plus. So this is an optional reporting level. It is not required under Basic or under GCOM, the CRF. It is an optional level that cities can choose to report if they want to. We only apply this to Scope 1 emissions in the Basic Plus framework. So these are emissions from industrial processes and product use taking place within your city. There are no Scope 2 emissions, and Scope 3 emissions are covered under other Scope 3, but they're not part of the GHG framework at all. Any electricity used at facilities that may be part of an industrial process, where industrial processes might be happening, should be reported under 1.3.2 under industry. So we're only really looking at Scope 1 emissions from IPPU. So what is IPPU? It's a fairly complicated sector, and it's easy to be confused between IPPU and stationary energy. So I'm going to try and explain that to you. But also bear in mind, this is optional. So if you find it's all too difficult, then just switch off and don't worry. You're not expected to report on this. If you do have large industry in your city, it is recommended, but it's not expected. So IPPU are emissions from industrial activities and product use that are not related to energy. So it's emissions from industrial activity and products that isn't related to the use of energy. And so these are industrial processes, for example, production of iron and steel, use of certain products that contain greenhouse gases like air conditioning units, refrigerators, aerosols, as well as non-energy use of fossil fuels. So where a fossil fuel is used, but not for the purpose of generating energy, but for the purpose of an industrial process or lubrication, for example. The greenhouse gases can include CO2, CH4 and N2O, as we've discussed before. There are 4 additional gases that come under IPPU, and these are SF6, which is sulfur hexafluoride, HFCs, hydrofluorocarbons, PFCs, perfluorocarbons, and NF3, nitrogen trifluoride. So those are called the F gases because they all have an F in them, which is the fluoride component. So SF6, HFCs, PFCs, and F3, they're called the F gases, and they have very, very high GWP values. So 1 unit of an F gas has a huge, huge impact on climate change. And so even though they're very small in quantity, they can have a huge impact. And whereas before, when we were looking at CO2 and methane nitrous oxide, we know sort of methane is 25 times more powerful than CO2, N2O around 300 times. Well, these F gases can be 1,000, 10,000 times more powerful. So they're much more powerful, but luckily their quantities are very small because they do tend to be industrial chemicals. So this sector covers both industrial processes and product use. An industrial process is a process that chemically or physically transforms materials. And in that transformation, greenhouse gases get released. So it's a transformation of a product either physically or chemically that releases greenhouse gases. And product use is where greenhouse gases are released from the use of a product. For example, when you're using a refrigerator, when using a foam product or an aerosol, it gets released when you're using the product, but you're not transforming something, but you're using something. So 2 very separate subsectors covered by IPPU. Here you've got the table. So 4.1 industrial processes, which covers mineral products, chemicals, and metals, and is equal to IPCC categories 2A, 2B, and 2C. For 4.2 on product use, this covers lubricants, paraffin waxes in non-energy products. It recovers electronics production and where we use gases as a replacement for ozone-depleting substances. And that covers IPCC categories 2D, 2E, 2F, 2G, and 2H. And here's a useful table. You've got this in your notes, which shows the breakdown of IPPU between the product uses on the left and the industrial processes on the right, and it gives you the further breakdown of all these sectors. Now, for national inventory compilers, this is a very big sector, and a lot of time is spent estimating emissions from these sectors because it's difficult and there's a lot going on and you need lots of data. But for cities, often these activities take place outside cities, or they're not very significant. So for most cities, this isn't a big sector. At the national level, this is a very big activity and a big focus for national inventory compilers. But yeah, just a useful graph chart in your notes to see the bigger sector. Okay, so this is the GHG reporting table. As I mentioned, this covers just scope 1 and is covered by basic plus. So you don't have to report these emissions, they're optional, but recommended where emissions are deemed to be significant. Okay, so let's look a bit closer into industrial processes. So these cover 3 processes, or 3 industries. We have mineral industry, which can include the production of cement, lime, glass, the chemical industry, ammonia, nitric acid, adipic acid, etc., or the metal industry, which covers iron, steel, alloys, aluminium, magnesium, lead, zinc, etc. And this is where emissions are released as part of a chemical or physical transformation of materials. So you have an example here. So for example, if we're producing nitric acid, and you've got the formula there, as part of that process, N2O gets released. If we're producing cement, as part of the process of converting calcium carbonate, we release carbon dioxide. So we're releasing gases not by burning something to create energy, but by transforming a material to create another material. So that's the very key distinction to make. It's really gases are released as part of a chemical or physical transformation, and not necessarily by burning for the use of energy. We have 3 big main industry types: mineral industry, chemical, and metal. So I'm going to deep dive into each of these 3 a bit more. Don't worry about the formulas. I know the formulas can be scary. They're in here for those who do like to see them, and where it does help you to understand these processes. If it scares you off, don't worry. I'm not going to be testing you on those formulas. Okay, so mineral processes. We have 3 main processes: cement production, lime production, and glass production. And in these cases, carbon dioxide is released through the process, and you simply estimate emissions by looking at the mineral produced by an emission factor, which you can find in the IPCC reports or in any national report. So to calculate emissions, you would identify your big industries within your city boundary. You would determine annual product output and materials used by contacting the operators or national inventory compiler. You then determine emission factors, and if you can't determine those yourself, you would use IPCC to find those emission factors. So a fairly easy process. Quite often, though, industries aren't comfortable sharing their data with you directly because it can be commercially sensitive and therefore confidential. And so often it's quite difficult to get data at an individual sort of industry level or individual plant level, but at the national level they do sort of aggregate them, and so you can either take that data and then scale it to your city, or you can make an assumption. You know, we think it's this big, this is their output, this is their profit margin, this is their turnover. You can make an assumption based upon the size of the operation and therefore how much they produce. But be aware that quite often companies don't like sharing commercially sensitive data So you may need to make assumptions here as well in terms of the size of the operation. Okay, chemical processes. Greenhouse gas emissions arise from the production of various inorganic and organic chemicals, and the emissions released depend upon the technology used. And often these can be measured through a technology within the facility to measure emissions directly. If that is the case, it's very easy to do the calculations if you can use the data. If not, you might need to base it upon total production activity at the facility. And again, you've got the same process here. Identify your processes, determine outputs or inputs, look at the technology used, determine emission factor, and if you can't determine one, use the one from the IPCC guidelines. And then finally, metal processes. This can release CO2, CH4, SF6, and HCFCs, and this is the production of steel, alloys, aluminium, magnesium, lead, zinc. And again, the emissions here depend upon the technology and the raw materials used. And similar to the chemical industry, they do tend to be measured through a continuous emissions monitoring system within these facilities. And the same process, identify the major industries in your city boundary, determine outputs or inputs, technology used, find an emission factor either from your industry body, your national inventory compiler, or use IPCC guidelines. And then you've got this table in the GPC, which gives you an insight into the different different equations for calculating emissions from industrial processes. You know, in this case, for cement, we've got cement, we've got lime, we've got glass, we've got metal industry. So this really gives you a good idea of you know what's going on. But if you decide this isn't relevant to your inventory, no need to read that chapter. If you do, then I would very much deep dive into this particular chapter to find out more about industrial processes. You'll also find the Berth 3 report as a very useful source to look at what industry is operational within Malaysia and what are their total emissions. So you've got data here broken down by industry type and giving quite a bit of detail. And again, you can see here also very well the use of notation keys, NE not estimated, NO not occurring. There's an additional one for national inventory compilers called NA, but which we don't use within city reporting. But again, just a good example here of both the breakdown by subsector, by category, and the use of activity data, of emissions data, and also of notation keys. Okay, so that is products, industrial processes. So any questions before we continue on to product use? Okay, so while industrial processes may not occur in your city, product use absolutely does. But again, these are optional categories, but product use takes place in every single city. So if you did want to go for a basis plus inventory, you will need to report product use emissions because they will definitely occur in your city. So product use, you know, is where you use products that release through the use of those products, not through any kind of combustion, but through just using the products that release greenhouse gases. And so products like refrigerants, foams, aerosol cans can release these very potent greenhouse gases like HCFCs. They're present in many consumer products, from trainers to asthma inhalers to aerosol cans, to air conditioning units, to paraffin wax. You know, they're very common in everything we do. Luckily, they're small in volume, but concerningly, these gases are very powerful and increasingly, you know, having a bigger impact on the climate. So there are four main subcategories under product use, and they're non-energy fuel products and use of solvents. So this is really where we're using fossil fuel products, but not for an energy use, but for a non-energy use. We have the electronic industry, where you know we're using products like photovoltaics, heat transfer fluids, semiconductors, which all have an impact on greenhouse gas emissions. The third category is where we're using fluorine substitutes for ozone depleting substances in air conditioning units, in refrigerators, asthma inhalers, and also there's another category called production and use of other products like electronics insulators. But I'll go through each of these in turn and explain them to you. So non-energy fuel products and use of solvents. And these are fuels and solvents consumed in industrial processes. And they're included, I've highlighted this in bold, they're included in IPPU when fossil fuels are used for their primary purpose, for lubrication or coating. So if a fossil fuel is used for lubrication and coating, it comes under IPPU. If it's used for combustion or as a feedstock, then it's, if it's used as combustion, it's under stationary. If it's used as a feedstock, it's part of a chemical or physical transformation, it comes under industrial processes. So think about the use of the fossil fuel. And if it is to generate energy for combustion, it comes under stationary energy. If it's used as part of an industrial process that seeks to chemically or physically transform materials, it's industrial process. If it's used for lubrication or coating, because it's slimy and sticky, then it comes under product use. So the table on the right, you've got the examples. So lubricants in transportation, to keep vehicles lubricated, to keep machinery lubricated, you tend to use a lot of lubricants. Paraffin waxes, candles, paper coating, adhesives, food production, packaging, all use paraffin wax. So again, that's a use of a non-energy use for fossil fuels, essentially for fossil derived products. Bitumen, road oil, and other oil thinners. So for example, bitumen is used in paving roads. Again, that has a release of greenhouse gas emissions. And then finally, white spirit, kerosene, some aromatics, where they're used as solvents, for example, for dry cleaning or for paint thinners. So again, think about the use of the product, and if it's not combustion, but it's used, as a product, then it should be reported under product use. This is just this slide just explains some of the formulas. So to estimate CO2 emissions, you would multiply the non-energy use of the fuel in terajoules by the fuel carbon content, by this fraction of carbon oxidized during use, by the molecular ratio between CO2 and C. Again, that's just for those people who like to understand the formulas. If you don't, then don't worry about it. To estimate emissions, you need to know how much fuel and solvents are used within your city boundary. You need to know which fuels are used and which solvents are used in your city boundary, how much is consumed, and the emission factors. And you can obtain that data from sales data from fuel and solvent suppliers, from your national inventory, or look at your national production import-export data to find that data. Again, we're not talking here about solvents used at home. Quite often, this is often solvents used in industrial processes where the quantities are much greater. But they will be used at home as well to a much smaller degree. But the majority will be used in industrial facilities. But they're also used. I mean, let's go back up here. You'll find a lot of these products also used at home, but in much smaller quantities. Okay, so moving on to the next subsector, the electronics industry. And this covers several advanced electronics manufacturing processes which utilize fluorinated compounds for plasma etching intricate patterns, for cleaning reactor chambers, all of which release greenhouse gases, in the semiconductor industry, the thin film transistor flat panel display industry, and photovoltaic manufacturing industry. So this is where we use products within the electronics industry. So this is not at home. This is very much using products within the electronics industry. And in the process here is you would identify major production industries within your city, focusing on electronics, look at their production capacity, look at which technologies are used, any control technologies, and then find any, either find out if they have direct emission control systems, which you could use to measure emissions directly, or find other methodologies or emission factors from IPCC reporting. But if you have a big semiconductor industry, or even a small one, if you manufacture photovoltaic panels, solar panels on your city, then they will use fluorinated compounds, these F gases, which are highly effective industrial gases, but they of course have a big impact on climate. You'll find them being used in the electronics industry as well. Okay, so then this is fluorine substitute for ozone depleting substances. You may recall back in the 80s, a huge hole in the ozone layer was discovered, particularly above Australia, being caused by CFCs. I think it's 70s and 80s. A major protocol, the Montreal Protocol, was enacted and sought to ban what was called CFCs, which were damaging the ozone layer. And to replace those CFCs, they used HFCs and PFCs, which didn't impact on the ozone layer, but they had a huge impact on the climate. So we're now trying to phase out these HFCs and PFCs because of their climate impact, but they're still very widely being used because they're such strong chemical properties that they're being used. They're used in air conditioning, so all your air conditioners will have these F gases in them, in your refrigerators, in fire suppression, explosion protection, aerosols, solvent cleaning, foam blowing, and many other applications as well. So you'll find that a lot of these gases are used in everyday products without us really knowing them, and they'll be in every single home as well. So this is more difficult to capture this data, so you would tend to collect data based upon the volume of gases sold by the industry, because they sell these gases to retailers and businesses that produce these products. So the best way is to contact industry to ask them how much are you selling, how much are you buying, and then kind of just sort of find out the emission factors as well. What you can also do is use national data and scale that to the city, assuming that these products are used equally across your city boundary. But yeah, this is particularly from air conditioning in climates like in Malaysia. You'll find this is a big source of F gases and greenhouse gas emissions. Okay, so the final subsector was other categories. So I'm not going to cover that because that could be anything. And the three main ones I've covered now, which focus on non-energy use from solvents. We have the electronics industry, and finally we have the F gases replacing ozone depleting substances used in refrigerators, air conditioning, and a host of other both business, industrial, and retail products. Okay, so the next question then becomes energy or IPPU. This is a really big question, like in terms of where do you report the emissions? Allocation of emissions from use of fossil fuels between stationary energy and IPPU can be complex, and IPCC guidelines give a very clear definition. They say for energy, it's the combustion of fuels for distinct and productive energy use. So distinct means the purpose is to create energy, and productive means there is a use of that energy. You're not just creating energy for the sake of creating energy, like flaring. You're burning fuels, but there's no energy capture. So it's productive energy use. IPPU is the heat released from use in hydrocarbons and chemical reactions in industrial process. So this is all the use of hydrocarbons as industrial products. So a real focus there on sort of the release of the release of something as part of a process, and not in terms of combusting fuels to generate energy. The GPC follows IPCC guidelines and defines fuel combustion as the intentional oxidation of material within an apparatus that is designed to provide heat or mechanical work to a process or for use from the apparatus. So energy and fuel combustion is very much focused on there being a generation of energy for a productive use. Whereas for IPPU, the difference is it's not about energy, it's a release of a gas as part of a process. So therefore, if the fuels are combusted for energy use, they be counted under stationary energy. If the fuels are transferred, or if the derived fuels are transferred for combustion in another source category, emissions are reported under stationary energy as well. So anything to do with combustion is captured under stationary. If combustion emissions of fuels are obtained directly or indirectly from feedstock, so we're talking about feedstock here, not energy, it's IPPU. If it's heat released from a chemical reaction, it's IPPU, and own emissions are unrelated from activities or product use, unrelated energy use are reported under IPPU. So the key thing is If it's energy use and productive energy use, it's stationary energy. Everything else you put under IPPU. But again, this is only relevant if you're focusing on the IPPU sector. But the key thing is productive energy, and so combustion and combustion for productive energy use is stationary energy. Everything else would come under IPPU. Okay, so I'm going to test you on that, obviously. So I've got a Menti exercise ready to allocate these different activities to either the stationary energy or the IPPU sector. So I'm going to ask you all to switch over to Menti again. So menti.com, code 71788262. And as always, please give me a heart when you have logged in. So 71788262. And let me just swap my screen so I can show you my Menti screen. There we are. Yep. And again, this is a very difficult sector, so if you get it wrong, don't worry. You may not need this knowledge anyway, but it's useful to know. And as part of the, well, it's a lot of HUDs there. And as part of this exercise, you know, it's also helping me to explain to you again what the differences are and give you examples of how they're different. Okay, so give yourself a name if you haven't already done so. Just waiting for a few more to join. Okay, so let's get started. So again, you're selecting the correct sector to allocate these emissions to. So CO2 released from a cement plant through heating calcium carbonate to transform into calcium oxide and CO2. Is that IPPU or stationary energy? And again, remember, stationary energy is the combustion for intentional combustion for useful energy. Well done, guys. Full house starting off with. Great. That's obviously an industrial process. Next one. CO2 emissions released from a cement factory through burning coal to heat calcium carbonate. Okay, so this is, again, this is very, these are difficult sectors. This is stationary energy because we're talking about it's through burning coal. So we're burning coal, we're combusting coal to heat something. So it's the intentional combustion for productive energy to heat CaCO3. The heating of the calcium carbonate will release CO2 as well, because that's the transformation as we discussed in the last question. But the process here is CO2 emissions released through burning coal. So the emissions from burning coal is stationary energy, but then the CO2 released through transforming calcium carbonate is industrial processes. But in this case, because the question relates to the burning of coal comes under stationary energy, but the release from calcium carbonate being heated is an industrial process. Okay, next question. The purposeful combustion of lubricants in an engine. The purposeful combustion of lubricants in an engine. IPPU or stationary energy? Okay, this was a difficult question again, and the correct answer is stationary energy because it's the purposeful combustion. Whenever we combust something, we're burning something, and this is the intentional combustion of lubricants for a productive energy use in an engine. If the lubrication was used to coat something, then it wouldn't be combustion and it would be IPPU. But we're talking here about the combustion of a fossil fuel, and therefore it comes under stationary energy. So anything that we combust, anytime we burn a fossil fuel for energy, it comes under stationary energy. Okay, next question. CO2 emissions from natural gas used as a raw material during ammonia production. CO2 emissions from natural gas used as a raw material during ammonia production? And the correct answer is IPPU. Again, we're not talking about combustion here. We're just talking about the release of a raw material during a production process. So this is a release as part of a industrial process, in this case, the production of ammonia, which uses natural gas, but we're not combusting or burning the gas. It's being released as part of an industrial process. Burning fuels for energy use. Burning fuels for energy use. Okay, that's stationary energy. Again, we're burning something. It's the intentional combustion of a fuel for energy use. Burning of wax candles. The burning of a wax candle. IPPU or stationary energy. The burning of a wax candle. So this is a trick question. So we're talking about burning something, and burning is combustion. Again, when you think of combustion, always think stationary energy, because you're burning it. You're burning a fossil fuel, a wax candle. But candles, we like candles for light. So in this case, it's the intentional combustion for a productive energy use. In this case, the productive use being light. So this could be at home. You're burning a candle. It's stationary energy because it is a intentional combustion for a productive energy use. If we use the wax to lubricate something, it could be IPPU. But in this case, because we're burning something with a productive energy use, in this case, the light, it comes under stationary energy. Release of emissions from use of wax as a lubricant. Release of emissions from use of wax as a lubricant. Okay, correct. And the answer is in the question. It's use of wax as a lubricant, and a lubricant is an industrial product use. So correct. Okay, I think we've got one more question in this round, and then we can have a look at the interim scores. Yeah, final question for this round. Emissions from a chemical reaction that releases heat. Emissions from a chemical reaction that releases heat. And the correct answer is IPPU. In this case, it's releasing heat, but the main purpose here is a chemical reaction. We're not burning something for heat. We're starting a chemical reaction, and the emissions are coming from the reaction. The heat is a byproduct. It's not the main purpose of the process. So in this case, it would come under IPPU. Again, going back to that definition we talked about earlier, for stationary energy being the intentional combustion for a productive energy use. In this case, the heat is a byproduct, and the main purpose here is a chemical reaction that releases those emissions. Okay, let's look at the interim scores, see who's taking the lead at the moment. Looks like we have Thanos in the lead, followed by Ribbits and Magical Rhino, with Finest Soul and Tom closing out the top 5. Okay, we'll come on to this again when we do a follow. But for now, let me take you back to our main presentation. There we go. Great, and there you have the answers. Again, this is a difficult sector, but always just go back to this definition, which I think is the best one. The combustion of fuels for distinct and productive energy use is stationary energy. Everything else would come under IPPU. So always think around, first of all, are we combusting a fuel? Are we burning a fuel? And is there a distinct and productive energy use? If yes, stationary energy. If not, then likely IPPU. Okay, so the next I want to start the exercise for IPPU. We'll start this after the break. So I'll introduce the exercise. We'll then take the break, and then we'll get started. There is a question there in the chat box which I haven't answered yet. A question around what about e-waste recycling industry activities. So e-waste, if again the question is depends on what processes take place. If all they're doing is they're collecting the recycling materials and they're packaging them and they're using energy in that process, it's just using energy to manage a process, and that will be stationary energy. If they're breaking products down, rewiring them, melting them and generating and using additional products, then that would indeed become an industrial process. So it depends upon what activities take place. If it's e-waste, so it's electronics, and they're recycling the materials to create new materials, and as part of that process, if they create and release greenhouse gases, then yes, it would be IPPU as well. I'm not an expert in the e-waste sector, but I would imagine that there would be a good chance that they will be using either additional F-gases or they'll be releasing F-gases as part of the recycling process. So again, if you have a big e-waste sector in your city, then it's certainly something you would need to look at. So again, I would imagine there would definitely be emissions related to that industry, because both in the recycling activities in breaking down and extracting the useful products, but also in the production process of creating new materials from those recycled products. I think that's the only question that I missed. Okay, just before I continue with the exercise, any questions on IPPU? It's a difficult sector. The first thing to decide is do we want to include it? Is it significant in my city, yes or no? And if it is, then decide, well, how am I going to collect data? Is it do I just have a few facilities, or do I have multiple? And then begin to speak to colleagues, to understand what level of activity takes place, and also, are those emissions going to be significant, and is it worthwhile for me to collect that data? In the practical, we're going to be using a scaling approach, again, just to get a feel for the ballpark figure for these sorts of emissions. Okay, so let me introduce the exercise. So we've got sort of 5 exercises. I'm going to give you 4 of these for homework, just to save time during the session today. So for homework, what I'd like you to do is to first of all identify all major industrial facilities in your city and add them to table 1. Then identify all significant product uses taking place in your city and add them to table 1 as well. So again, just list the main industrial facilities and the main product uses. And again, go back to the categories. I've got the checklists in the workbook. So these are your main industrial processes. Do you have any of these facilities in your city? If yes, you should definitely include them. If no, then don't worry about them. And same for product use. Are any of these big product uses taking place in your city? So obviously, you have tons of air conditioning units. So think about, do we want to capture those? But have a think about the other sectors as well. Do you think there are significant uses within your city? And then make a decision, do I want to report on them? Again, you don't have to, because it's basic plus, but it might make your inventory more complete. But it also depends upon, do you think you can get good data for it? And again, one purpose of an inventory is to drive action. And if there's no action going to be taken on this, because maybe it's more national government controlled, then think about, is there actually a benefit in me collecting and reporting this data if it doesn't lead to action by the city? So some things for you to think about. So exercise 1 is just for you to identify all major industrial facilities in your city and identify all significant product uses. And then after the break, we're going to move into this exercise where we're going to estimate emissions from product use in your city using the consumption-based method and national data reported in BER 3. So with that, we'll break for 10 minutes and we'll come back at 22, and I'll hand over to Deep to start the break. And then make sure you have your workbook open when we return, and I'll introduce the exercise to you so we can get started on that.
Thanks, Michael. How many minutes should we go on break?
I think 10 would be good. I think that was the feedback from last time, just to have slightly longer breaks to give everyone a chance to fully soak everything up and yeah, have a quick break as well.
All right. Everyone, let's just have a 10-minute break and come back before 3:39, sorry. Michael, shall we continue?
Yes, that'd be great. Thank you, Deep. Okay, welcome back. I hope you all had a chance to absorb all the information from before the break. And now we're going to do the exercise. We're going to estimate greenhouse gas emissions for product use only in your city using a consumption-based method and national data reported in Berth 3. So I'll give you the introductions and then I'll hand over to you to work on this on your own before moving on to the next part of today's webinar. So again, as I mentioned, product use is everywhere across the whole city. And it may be significant, it may be not that significant, but there will be levels taking place in your city because you have air conditioning, you have refrigerators, you have businesses, you have homes, and they use a lot of those products. Even if you don't have a big electronics industry, you will still have some of these uses in your city. That doesn't mean you need to report these emissions. Again, this is basic plus, this is optional, but you may choose that you would like to. So if you can open your workbook and go to module F, called IPPU and a FOLU, and you should have an exercise set out there, or at least a table which we're going to be using to do this exercise. So if you can all make sure you open your workbook and you go to module F. So I'll give you a second to open that, and you'll see there are two tables. One to estimate greenhouse gas emissions from product use, and the other to estimate emissions from fermentation and manure management. That's the exercise for FOLU. We're focusing just on IPPU now, so table 1. And you'll see a column with categories and a column with greenhouse gases in terms of gigagrams of CO2 equivalent. And we're going to basically copy the categories. We're going to identify the categories and copy the emissions across from Berth 3. If you then scroll to the right in your table in the workbook, you'll see the different gases and you see total. Behind total, you've got scaling factor, national value, city value, ratio, and city level greenhouse gas data. So again, what we're going to do here is we're going to copy the emissions data from Berth 3 for the whole of Malaysia, apply a scaling factor, and again, for you to decide the appropriate scaling factor, either population, GDP, or something else, scale the data to get your city total. So we've done this calculation quite a few times by now, so it should be fairly familiar by now. And then you're going to basically do that calculation for each of the categories that you identify as having emissions, and then total them up to get your total emissions at the bottom of that particular table. This is the data we'll be using in Berth 3, and you've got the handouts, you've got the slides where you have this data. So we have non-energy use, non-energy fuel solvents and use of, sorry, non-energy fuel products and use of solvents. And you've got the Berth 3 report. This is 2D. In this case, you can see just notation keys. So you've got basically the table split into two: activity data, and you've got the emissions data, but it's all notation keys, so we don't have to copy this because the assumption here is it's either not estimated or it's not occurring. So you can leave that one blank. We then move on to the electronics industry, 2E, and you'll see the table split into two. We've got the same data, or the same subsectors, reported in two different types. One is emissions in individual mass units. So that is, for example, in tons of methane, tons of SF6, tons of N2O. And below that, you've got them converted into CO2 equivalent. So use the bottom table because that's more useful, because we don't then need to convert them using global warming potential factors. So you've got all the data there for electronics industry, some notation keys, some data, but use the bottom half of the table to total emissions. Then we move on to fluorine substitutes for ozone depleting substances, category 2F, and again the same two tables. The top one in original mass units, so the units of the actual gas, and the bottom one converted into gigagrams of CO2 equivalent. And you'll see some activities here are significant and some gases are significant, whereas some gases and some activities aren't that significant. So again, have a look at this table, the bottom part, to copy data across into your table. Then production and use of other products. Again, you've got two tables here. The top one listing emissions in original mass units, and the bottom one listing emissions in CO2 equivalent. Again, a lot of notation keys, a lot of NEs, not estimated, which is allowed at the national level. It's not allowed in the GPC. So just copy across those activities where emissions do occur and copy them across according to the right gas. And there's a second bit of the production and use of other products category, which is 2G. And in this case, for these two tables, we just have the gases reported in CO2, N2O, and methane. In this case, there's only one activity that has reported emissions, which is medical applications, and N2O. In this case, we need to convert this into CO2 equivalent first before you report them. So we have the activity data in the first half, then the emissions in the second half. But the emissions are in original mass units, so we need to convert those using the global warming potential factor for nitrous oxide. So that's the only modification you need to make to that calculation. Okay, so that's the exercise. You have all the data in your handout, all these tables from Berth 3. You have the slide deck as well. So I'm going to pause now for 15 minutes to let you do the exercise. Actually, let's make it 10 minutes to save some time. And all you're doing is you're copying across the data from these tables into your table. You're going to enter the category, then the amount of gas per individual gas. So where there is a gas occurring, enter it in the right column, and then add them up at the end, and then scale them together to get your city total. Bearing in mind that for the last category, for this one, for N2O emissions for medical applications, you'll need to convert that using the GWP value for N2O as well. Okay, so let's pause here, and you'll have until the top of the hour to finish the exercise, and then we'll reconvene and discuss the results. Actually, I was going to give you 10 minutes, so let's come back at 5:02. So give you 10 minutes for the exercise, and then we'll just go through the answers together. So you have until 5:02 to complete this exercise. I'll leave the tasks on here. I'll leave this one on. But yeah, you've got the notes in your notebook and in the slide deck. So 10 minutes, and we'll reconvene, and we'll just go through answers then. Before that, any questions on this exercise? No, if that's all clear, then please get started. If you need more time, then let me know at the end as we approach the end that you need more time. I'm happy to extend it. But for now, we'll give you 10 minutes to get started. But if you do feel you need more time, then just say on the slide deck, and we can easily extend by 5 minutes. But off you go, and I'll be online. So any questions, just speak up or use the chat box, and I'll gladly answer your questions. About 10 minutes from now. So I think that's going to be sort of 4 minutes too, but I'll give you a warning before that. Okay, so I'm going to assume you've all finished. I know that's a big assumption, but if you do need more time, let me know. But otherwise, we're going to crack on. We'll have another 10-minute break as well before the next exercise. So if you still need to finish something, you've got a bit more time then as well to finish that exercise. Okay, so there should have been a fairly straightforward process. You've done this before. It seems complicated because you've got all these different columns of data and all these different numbers. But all you're really doing is you're taking data from Berth 3, you're finding data there, you're identifying which activities, which sectors, which categories apply to your city. In this case, which categories have data. So you're going to find those categories that are relevant to your inventory. You then add those to the first column. You then find the data for those particular sectors, and to your column, you scale them and you add them up. So a very similar process you would do within your own cities to identify which activities are significant. In this case, which activities have emissions. You then find the emissions data. You then scale them, and you then add them up together. Yeah, hopefully that should be a fairly straightforward process for most of you by now. But again, it does very much mimic the exercise you always do, is you identify which activities are significant, where is their data that shows activity, copy it across, check the units, which is very important. Always check the units. Is it in gigagrams of CO2 equivalent? Is it in gigagrams of the original gas? Do I need to convert it using a global warming potential factor? Do I need to convert the units? So always look at the units very closely. And one thing I noticed, having gone through most of your homework exercises already, is that not everyone is really focusing on the units very clearly, but always pay very careful attention to the units to make sure you're converting the units correctly and appropriately where you need to before you sometimes add up or before you multiply. There's a question. Will there be any cases where cities are using GDP by economic sector as scaling? So not just GDP as a whole, but by sector. For example, in KL, we don't have a lot of industrial-based land, so maybe we can scale it using the city's manufacturing sector GDP or national manufacturing GDP. Absolutely. If you have that level of data, I would. The more specific you can make the scaling factor to the activity, the more useful it would be. So if you have that breakdown by activity, the output by activity, I would definitely use that. I'm not aware most cities have done that. They tend to just use GDP as a whole. But if you have that data and you feel confident and you feel that data is robust, then I would actually encourage you to use that. The closer the scaling factor is to the activity, the better. Yes, by all means, I would encourage that, but I'm not familiar with any other cities applying that. But that's really more because they may not have access to that data, and they may just use GDP as a whole because it's easier to use and they have it at hand. Okay, so let's move on to the next bit. So homework for you guys are these two final exercises, which is to report your data in table 3. This is table 3, remember. So in this case, we've not done 4.1, which is scope 1 emissions. So we can simply put NO, not estimated. And remember, this is basic plus. And in basic plus, we can use NE, not estimated, because it's not a mandatory source. For a mandatory source, we can't use NE because we have to estimate those emissions. But because this is basic plus, we can use NE. So for 4.1, we'll just simply put NE. Same for scope 3, we'll put NE. For product use, we have not estimated those. So whatever total you got in the previous exercise, if you can copy those emissions into 2.2, and again, it's an approximation, but we've done the estimate. And then we put NE for the scope 3 box. So you should have this complete as well. So once you finish your exercise, please do copy this across into your GPC table in the table 3 tab in your workbook. And same with action plan. Again, just identify for yourself some actions you would like to take following this series of webinars to think about maybe getting more data or finding out more about what actually happens in your city to determine are these emissions likely to be significant or not. Again, if they're significant, you're recommended, not required to, but recommended to include them. If they're not significant, don't worry about them because it's not really worth your time. But definitely have a discussion in your city whether you would like to measure these as well, if there's a benefit, if there's a purpose, and above all, if they're significant. Okay, so that's it. We now move on to the next sector, which is AFOLU, which is the land use sector. And this is a basic plus source as well. And you're required to report all your emissions resulting from AFOLU within scope 1, basic plus. So scope 1 is all in-boundary emissions from agricultural activity and land use activity. Scope 2 isn't applicable, and scope 3 isn't applicable, but may be reported as other scope 3. But for now, we're just focusing on scope 1 AFOLU. That's what's required for basic plus. But again, basic plus is optional. It's not a mandatory requirement. Okay, AFOLU. It stands for agriculture, forestry, and other land use. And given the highly variable nature of land use and agricultural processes across different countries, this is one of the most difficult sectors to measure greenhouse gas emissions from. It's outside, it's huge, it's not controlled often, it's very variable based on the land, the weather, processes. So it's very, very difficult to measure these accurately. And so we're going to make some assumptions and going to use some calculators to do so. Some cities where you have no big agricultural land, or forestry will have no big FOLU sources. So often for dense urban cities, this will be a very small sector. If you have a bigger, say, metropolitan area with forests or some farms, then this might start to become a significant source. It depends upon your geography. If it's mostly urban, then likely to be insignificant. If it's semi-urban, part rural, then you're likely to have some FOLU emissions as well. But again, these are optional. But again, if they are significant, you are recommended to report them. FOLU is broken down into 3 subcategories: livestock, land, and aggregate sources and non-CO2 emissions on land. So this is basically livestock, land, and another category. So we have them here. So livestock, basically the emissions arise from enteric fermentation, in other words, farting, and manure management, and that's IPCC category 3A. Land is from changing land use, particularly from deforestation, and that's IPCC category 3B. And aggregate sources covers fertilizer application, rice cultivation, and that's IPCC category 3C. This is how you report them. Again, they're all basic plus. V1 for livestock, V2 for land, V3 for aggregate sources. And you also have other scope 3, which are basically the life cycle emissions, but they're not required at all by basic or by basic plus. Okay, so this chart gives you a good indication of all the sources of emissions coming from land. So we have methane from rice cultivation at the right. We have CO2 from soil respiration. We have fertilizer application, nitrogen fixation, manure management. We have cows farting and burping. We have fire, either incidental or intentional. We have litter. We have biomass. We have biomass harvesting. We have harvested wood products, which tend to store carbon for a bit of time. So a lot of different activities taking place, and it's a very dynamic ecosystem. These are the main greenhouse gas emissions and the main sources. So we have on the right, rice cultivation leading to CH4, to methane. We have liming, fertilizer application releasing CO2, but once it gets applied to the soil, it can also release N2O. We have methane being released from livestock, from animals directly, or from manure management. We have the burning of biomass, which releases N2O, CH4, and biogenic carbon. And we have wood products, which are basically wood products that get taken out of circulation for a limited period of time. It's where you say you have some furniture where it's a biogenic component, but it gets locked away for 10, 20, 30, 50 years, or even longer as a wood product. So data needs, again, it's a complicated sector. For livestock, though, all you need is number of animals. And based on that, we can estimate emissions. For land, you tend to just need the area of land by type and the original area of land if it was converted. So, and then we have calculators that can do the rest. For the aggregate sources, depending upon the activity, you'll need the land area, you need tons of fertilizer applied, you'll need livestock in terms of your management, you need rice production or cultivation. So depending upon the emission source will indicate what type of data you'll be needing to collect. For the practical later on today, we're going to be focusing on livestock on the top left column. But bear in mind, depending on the activity that's taking place in your city, that will guide what data you'll need to collect to estimate emissions. Okay, so let's go through each of those 3 categories in turn: livestock, land use, and aggregate sources. So livestock releases emissions through enteric fermentation and through manure management. And CO2 emissions of livestock are not estimated because it's assumed that what gets released from this process gets absorbed as well. So it's a very small cycle. We're not expecting any additional releases of carbon dioxide into the atmosphere. So that's why we're just looking at methane and nitrous oxide. So enteric fermentation is the digestive process by which carbohydrates are broken down by microorganisms into simple molecules. This happens in the gut of the animal, and a byproduct is the release of methane. The amount of methane is driven by 3 key factors: the number of animals you have in your city, the type of animal, and therefore the type of digestive system. Some animals are more active, have a more active digestive system than others, but also what kind of food they consume, because that will also determine how and what they digest. So the basic calculator is simply your animal type multiplied by an emission factor that takes into account the type of animal and the type of diet they're being fed on. Those emission factors, you can get those from IPCC. Activity data will be obtained from different sources. Berth 3 is a very good source, but again, it's national data. But you might have a list of farms and animals in your city, or there might have been a study done by a university or an agricultural body that gives you a data on the number of animals within your city broken down by type. But the type is important because, as I mentioned, the emissions come from different animals. It varies by their digestive system. But emission factors can be fairly easily obtained from IPCC. So this is an example of the IPCC emission factors. This is from one of their reports. I know it's quite small, but I just want to highlight a few things. So in the top box, we have this table is just for cattle. So you see a difference between regions have different emissions, but also between dairy and non-dairy cattle. So again, the region is important because it's an indication of diet, but it's also an indication of the type of dairy, the type of sector they're in. Is it very commercial? Is it not that commercial? And also the difference between dairy and non-dairy cattle. So they will have very different emission factors depending upon their digestive systems. So important to know that don't just apply a random emission factor that you find, but bear in mind this changes quite a lot between geography, but also between the type of animal. And the table in the top right, you've got emission factors for other animals between developed countries and developing countries. Those differences aren't that significant, except for sheep and for swine. But for cattle, it is very different. And you'll see the difference for North America. A dairy cattle releases 118 kilograms per head per year, whereas in Asia that is 56, and in Africa that is 36. So again, apply the appropriate emission factor depending upon your stock. Okay, so we can find activity data in Berth 3, which actually lists the number of animals in Malaysia in that second column. You have the activity data. So we have over 700,000 cattle in Malaysia, 46,000 dairy cows, etc., and 4,000 horses, for example. So this data is very useful. We're going to be using this data as part of our exercise. But your city may have better data for your own city. You may have a few urban farms. I don't know, but if you do, then it might be useful. And it's a very quick exercise to estimate emissions from animals. And then you've got the emissions from methane and nitrous oxide in the columns next to that. Okay, so that's enteric fermentation. That's the digestive process taking place. For manure management, which includes dung and urine produced by livestock, they can also release emissions. This takes place during the storage and treatment of manure before applying it to land or using it as feed or fuel. So it's the step whilst you're managing the manure before you apply it to something else. And during that management stage, emissions occur because of decomposition under anaerobic conditions and through the nitrification and denitrification of nitrogen contained in the manure. So this is the storage and treatment of the manure once it's been released and once you're managing it before you apply it elsewhere. And that's storage. During that storage, emissions can occur. Again, you can the key thing here is obtaining data on the amount of livestock, because that will also give you a good indication of how much manure they produce. You can also try and get data from government or agricultural sources. Emission factors, again, try and use country-specific emission factors where you can. Otherwise, use IPCC emission factors, which may be lower in quality, but they're available as well. So then just deep diving into manure management for methane and nitrous oxide. So methane occurs based upon the quantity the percentage of manure composed, but also temperatures. There's a lot of activities taking place that will determine how much methane is released. Again, this should all be reflected in the emission factor. So you should all you really need to know is the number of animals, and the emission factor does everything else for you. But it does contain a lot of dependencies, and so if you can find any national data, that would be really useful. Whereas international data like IPPU emission factor data are less likely to be accurate because of the variability in conditions that drive emissions from manure management. N2O, again, these emissions are fairly complex, and they occur because nitrogen is fixed in the atmosphere, but also released from the manure through the storage phase, and data can be obtained from, again, the same sources we've discussed before. Here's the formulas. Again, I'm not going to go through this in detail. It's there for you if you want to go through that, and I've explained it on the left as well, exactly how that formula works. But it is a bit more complicated to estimate these emissions because there are so many different factors that need to be taken into account in estimating N2O for manure management. Okay, so that's V.1. That's 5.1. That's the livestock. Next, land use category, and the IPCC divides land use into 6 categories: forest land, cropland, grassland, wetlands, settlements, or other. And they say that all land should be assigned to one of the above categories. And in cities' case, it will most likely be settlements, obviously, because that's what makes up a city. Some land use may be classified into more than one category due to multiple uses that meet the criteria of more than one definition. Where that does occur, a ranking has been developed to make sure you assign land to one single category, and if it has some settlement on it, you classify it as settlement, then cropland over forest land, etc., etc. So you always kind of use the higher category of that bottom sort of list where you have multiple uses. Emissions as well as removals are based on changes in ecosystem carbon stocks that are estimated for each land use category. So each of these different categories have different activities taking place that will either sequester or release carbon, and we have emission factors or rate of change that sort of quantify those emissions. And this covers both land remaining in the same land use, so forest land staying as land use. There'll be a net change in the carbon stock, but also land use converting from one category to another. So if you're moving from forest land to settlement, there'll be a net change in emissions from that. So it's looking at both land that stays the same, but also land use that changes from one category to another will have a big impact on carbon stocks, either above ground or embedded in below the ground in terms of biomass and organic matter. And again, a key thing to note is when we talk about land use, we talk about carbon stock, just carbon. But when we talk about greenhouse gases, we talk about carbon dioxide. So as we did before, we need to convert any carbon stock into carbon dioxide before we can estimate greenhouse gas emissions by multiplying by 44/12, which is the molecular ratio between carbon dioxide and carbon. So looking at the 6 different land use categories, we have settlements. This includes all developed lands, including transport infrastructure and human settlements, cities, towns, villages. Cropland is cultivated land, including rice fields, agroforestry systems. Forest areas include woodlands. Grassland include pastures that aren't arable. So it's not arable land. So it's not cropland, but other grasslands with some woody vegetation. Wetlands is areas of peat extraction and land covered or saturated by water during all parts of the year. And then another category which is bare, soil or rock or ice, or lands that don't fall into any of the other categories. But the key ones for us will probably be settlements, cropland, and forest areas, where you might have a change between those, or you might have all 3 occurring within your city boundary. So these then are the different land use categories. So you can either have forest land remaining forest land, forest land converted to cropland, forest land converted to grassland, etc., etc. So this table basically shows you the different land use categories, which also includes land remaining as its current land use, or land use changing and being converted into a different land use. You only need to consider changes over the last 20 years. And because emissions take a while to release, any change in the last 20 years needs to be included. Anything beyond that, you wouldn't include, and you would just assume the land use stays the same. But any change in the last 20 years, you should consider as a land conversion, and not a land remaining the same within the same land use category. Okay, so again, a lot of formulas here. I won't go through detail on them, but just to know they are there if you wanted to go through them. But essentially what we're doing here is we're looking at the change in annual carbon stock, either by land use staying the same category or by land use changing categories. And you would need to find the size of the area multiplied by an emission factor is the easiest way of doing so. So large quantities of greenhouse gas emissions can result as a consequence of a change in land use. Examples include basically changing a forest land to cropland, and that could be, say, forest land into a biofuel plantation or into settlements. And where land use is changed, soil carbon or carbon stock in vegetation can be lost as emissions of carbon dioxide. If the change took place within the last 20 years, we need to capture that. Therefore, you need to look at any recent changes, but also any changes within the last 20 years, because it takes time for land to change and for the full impact to be to have had an effect. Any change beyond 20 years, we don't allocate, but any change within the last 20 years, we would allocate them on an equal allocation. So we assume the impact of the carbon change takes place equally over that 20-year period. And so it doesn't all take place the year the land use is changed, but it gets reflected over a 20-year period. So that's land use. It's difficult, but there are emission factors you can apply. And all you would need to do is to measure how much land has been changed from what category to what category, and then apply an emission factor to estimate those changes. The last category on aggregate sources basically looks at greenhouse gas emissions from biomass burning, liming, fertilizer application, direct application of N2O, but also indirect application of N2O, rice cultivation, and wood products, as I mentioned, that store carbon for a longer period of time outside of this system. A bit more detail here on those different processes. I won't go into detail on them because it's a lot of detail that you probably won't need, but it's there as a reference if you wanted to go through this yourself. The GPC provides formulas for all of these calculations. They're from the IPCC. They're all set out in the GPC. So again, if you want to deep dive into this, all the information is there. They are complicated, so if formulas scare you, maybe don't look at the chapter. But if you're comfortable with formulas, you'd like to know more detail, and you think this is applicable to your city, then please do have a look at those formulas. Biomass burning is an important consideration. Where biomass is burned for energy, the non-CO2 emissions should be reported under Scope 1, while the CO2 emissions should be reported separately because they're of biogenic origin. But where biomass is burnt without energy recovery, such as the burning of land or accidental fires, there's no energy, there's no purpose to that energy, and so they should be captured under a FOLU under aggregate sources. So biomass, when it's burned for energy, either in a wood oven or in a biomass incinerator or in a wood fire. If there's a purposeful energy, we report the CH4 and the N2O under stationary energy. The CO2 is biogenic in origin, so we report it separately, and that's captured separately in the Cirrus tool, but they do fall under stationary energy. But if the biomass is burnt without energy recovery, and in this case, when you're burning land for agriculture or an accidental fire, they're captured under aggregate sources under a FOLU. And you've got the calculation there. basically you look at the area of land burned, the mass of fuel available for combustion, the combustion factor, and an emission factor to convert that to greenhouse gas emissions. Okay, we'll do a quick exercise, and then we'll break. We'll go into our second break. So if everyone can please go back to Menti, and it's menti.com, code 71788262, and then we'll just test your knowledge on the FOLU. And basically what I want to just test out is your understanding of the separation between a FOLU and energy, because that's the critical discussion.
Michael, do we take a question? So I think,
there's just a question there. Yeah. So if an empty plot of land is converted into housing development, is it considered a land use change, assuming plot of land was cleared 10 years ago? So you could ask yourself two questions. If the empty plot of land was already, say, concreted over, then you wouldn't, because it's already then considered under the settlement category. So identify what land use category the plot was in. If it's in the same one that it's been converted to, then there is no change from a greenhouse gas accounting point of view. If the empty plot was, say, farmland or wasteland or agricultural land, and there is a land use change, it goes from cropland to settlement or from forest land to settlement, then you would need to include that. If it was 10 years ago, it's within the 20-year period, so yes, you would need to include that within your inventory. And you would include 1/20, you would estimate the total emissions for the land use change and apply 1/20, 1/20th to your inventory year. And you do that until the 20 years have expired, and then you no longer report those emission changes.
There's a question from Tan as well. Tan?
Thanks, Mr. Tip. Michael, forest land as defined in national inventory typically does not include urban green space. Is there a guideline how we can calculate carbon sequestrations by urban trees, for example?
So urban green space, it's not, because it's a created green space. It's an urban green space. It's not a natural space like you would have with a forest. The way you would do that is typically I would count the number of trees and simply base it on the number of trees. The vegetation doesn't tend to be that, have that big sequestration potential, and it's very mixed land use. You've got playgrounds, you've got sidewalk, you've got space for people, roads and paths for people to walk. I would simply count the number of trees you have, and based on the age of the trees, whether they've just been planted, estimate the sequestration from those individual trees as opposed to the whole park. What you could also do is you could estimate the green space within your city, the collective green space. You could also do some really cool work looking at the garden space across your whole city and estimate the sequestration potential of that land. But it is very variable, and it's not always very far from trees, very productive green land. It's subject to change quite quickly. So do make sure that when you do report these emissions, you calculate them, they're not going to change very quickly, because that would then make your inventory go up and down, which is what you don't want. So if it's just from a few key parks, it's fine. But I would focus more on the trees, because that's really where you have the big sequestration potential.
Follow-up questions. Would you apply this method you described just now to, say, reforestation initiative in city?
Absolutely, yes, absolutely. So if you're changing land use from a settlement to a forest, if you're creating an urban park, for example, and you're changing it from a concreted, asphalted area of land that has a paved area of land to a green area of land, I would definitely quantify that, because that is a sequestration potential, and it will help to reduce your emissions, and it's important to quantify that. It depends upon how big it is. If it is a small urban park or a pocket park, it's going to be insignificant compared to your overall city emissions. It might be a nice greening initiative, but from a greenhouse gas point of view, it's likely to be insignificant. If it's a bigger park or part of a collection of parks, then yes. But the key thing is to identify, first of all, how big is it? Is it quite big? If it is, then it could be significant. And then what's the land use change? If it is going from an unproductive use of land or a sort of a city use, like a concrete or a road, or it's been paved over to a green area, then you're likely to have a significant net absorption of CO2. So definitely include that. But look at both the size, both individually, like with the size of the parks, but also collectively. Can you add different bits up together, and do they give a big total? And also, what's the land use change? What is it changing from? And if it's changing from, you know, if it's not that great a green area and it's just got a few trees here and there, then probably not that big. But if it's a lot of trees in real dense green area, then more than likely those emissions could be quite big for your city.
Thanks, Michael. That's very helpful. Thanks.
But most cities don't tend to estimate photo emissions just from a few parks here and there. They do, the ones that do them within C40 anyway, are the ones that have big green areas like forests as part of their city, or they've converted like an old airport into a new park. So really looking at big areas. Some have tried to estimate emissions from all their gardens and all their parks and add them together using some GIS mapping. That land is variable, and often that green land will have been green for beyond the last 20 years. So you're not really going to get a big change in emissions there. It's really the big impact here is in land use change. And for most cities, it's the opposite way, where they are converting green space into streets and infrastructure and buildings. But if it's the opposite in your case, or you're intensifying the use of existing green space, then there may be a big opportunity there to quantify emissions.
Noted. Thanks.
Cool. So let's move on to the Menti exercise. Sorry, are there any further questions? And so next we're going to be, I'm going to ask you a series of 8 questions on whether to classify an activity under a FOLU or under energy. And then we'll take a break. Okay, so the first question. A steam plant generating electricity from sugarcane. Is that a FOLU or stationary energy? A steam plant generating electricity from sugarcane. Okay, and the correct answer is stationary energy, because we're generating electricity. So it's the intentional use of a fuel for electricity. So reporting that under stationary energy. And again, just going back to that. Sorry, just going back to the last question. It is sugarcane, so it is biogenic carbon, but you would report that as biogenic carbon under stationary energy. So, but definitely because it's an intentional combustion with a purposeful use of energy, it comes under stationary energy. Okay, next question. The periodic burning of land. The periodic burning of land, and this is a common practice in agriculture. Okay, and that is indeed a FOLU, because there isn't an energy use for this burning of land. You're burning it, you're combusting it, but there is no energy use, and that's critical for stationary energy. Domestic wood burning. Domestic wood burning, so burning wood within your home. Which is a very common activity in the winter in the UK and most of colder climates. Domestic burning of wood. Okay, and the correct answer is stationary energy. Again, it's biogenic carbon, so you report it separately, but you report it under the stationary energy sector because it is the intentional combustion of wood, and in this case, often for either atmosphere, for lighting, but also mostly for warmth as a heating fuel. Okay, next question. An accidental wildfire. An accidental wildfire, is that a FOLU or stationary energy? Okay, and that is indeed a FOLU. Again, it's accidental, it's not intentional, and there is no productive energy use, so it comes under a FOLU. The burning of biomass pellets. The burning of biomass pellets. And pellets are sort of manufactured bits of biomass, which you would tend to use in a big biomass plant to generate power. Is that a FOLU or stationary energy? And that is indeed stationary energy. Again, it's biomass. You report it separately, but it's the intentional burning within specific energy use. In this case, power or heating or cooling. A wood-fired pizza oven. A wood-fired pizza oven. Are those emissions of FOLU or stationary energy? If I'm making my pizza in a wood, I'm burning wood in a oven to make my pizza. Is that a FOLU or stationary energy? That is indeed stationary energy. Again, it's the intentional combustion of wood for a personal energy use, in this case to make my pizza through the heat. Again, it's biogenic carbon, so we report the biogenic carbon separately, but under the stationary energy sector. Okay, 2 questions to go and we'll get the scores. Shrub clearance. Shrub clearance. Is that a FOLU or stationary energy? Shrub clearance. Okay, that's a full house, and that's correct. Again, there's no intentional combustion for a productive energy use here. You're clearing, which is intentional, but there's no productive energy use here. You're just clearing it to clear the land. Okay, last question. A bonfire. A bonfire. Is this a FOLU or stationary energy? A bonfire. This is when you put everything, all your biomass waste onto a big pit and you just burn it. This is a sort of a trick question. I would put this under a FOLU because it is intentional combustion, but there is no productive energy use. It is, you know, you're just burning it. In most cases, you're burning it to get rid of stuff and to clear up debris and get rid of waste. Usually on a farm, you're just burning it. So that's why I would classify this under a FOLU, but these emissions are insignificant, so they would never feature in your inventory anyway. But just a trick question at the end. Okay, let's look at the scores. So we had Thanos in the lead. Looks like Joanna did best in the last round, but the final scores haven't changed that much, with Thanos still winning, followed by Ribbits, the Natural Rhino, and Barefoot Contessa, and Joanna making up the top 5. So well done. Congratulations to Thanos and everyone. Let's take a 10-minute break, and we'll come back and then we'll go into a bit more theory on the FOLU, and then we'll do the practical exercise before finishing for today. So Deep, let me hand back over to you to start the break. And welcome back, everyone. Hope you had a good break and a chance to soak everything in. These are the answers from the Menti exercise. Again, I'll share this with you in the follow-up notes. But again, the key thing here is the language we discussed also with IPPU. It's if there is an intentional combustion with a purposeful energy use, then it would be come under stationary. If it's accidental or intentional with no energy recovery, then it would come under a FOLU. Again, in some cases you might decide these things are different, and there's not just one right answer, because the term productive energy use can be different for different people. So just apply your own common sense, and if in doubt, always just ask a colleague. But to go back to that sentence, the intentional combustion for discrete and productive energy use. Okay, so we covered all the theory for a FOLU now. Those 3 subsectors, the main ones being for cities sort of really being livestock, if you do have animals, and land use change, where you do have a lot of green land, or if there's been conversion of land over the last 20 years. And where there has been, just identify what land has changed use, and use the formulas in the GPC to identify the difference in emissions, and divide that by 20, allocate those emissions each to the 20 years since the land use change, because that's when those emissions are expected to occur. And beyond that, you would no longer quantify it as a land use change, but it just becomes that new land use. Okay, in terms of sequestration, again, there was that question we had. A lot of cities are indeed actively trying to green their cities and plant more trees, create more parks, either big parks or pocket parks, or connecting parks, or create more greenery within the streetscape. If that is significant, then there might be an opportunity to quantify that. But the biggest opportunity will be in the trees themselves, and more so than the land, because the land is too disconnected really to if it's sort of pocket parks and trees here and there. So I would focus more on the number of trees being planted. That's, I think, your easier route, because land use change is difficult to demonstrate if it's just a small park within a largely urban area. Because again, the way we classify land use is by the main use of that area, which often tends to be urban within a city region. But then, so definitely focus on the trees you're planting, and you can then also use this as an argument to support city measures around urban greening to quantify the sequestration of those trees, in addition to providing a more pleasant urban environment and helping with urban cooling as well. So it can be one of the additional arguments that your leaders can use to argue for further urban greening. Okay, so next we're going to dive into the practical. Before we do so, any further questions on AFOLU at all? No, so let's go ahead. So your task is, again, same as before, is to first of all identify all your livestock activity in your city, any land use and land use changes within your city, and list them in table 1. That should be last 20 years, not 2 years. I'll get that corrected in the updated slide deck. That's for your homework. So separately to today's discussion, if you can find some time to just identify all significant livestock activity, so all big farms, and any major land use changes over the last 20 years, or any non-urban land uses in your city, and list them, because that will then help you guide if this is a potentially big source of emissions or big source of carbon sequestration. If it's not, don't worry about it. If it is, then do consider measuring these emissions and including them in your basic plus inventory. We're going to estimate methane emissions from enteric fermentation and manure management for a sample of livestock using the data in BER 3, just as an exercise. And then for homework, again, I'd like you to update table 3 in your workbook, and table 4 as well, if you do decide that this is a source I'd like to learn more about, and then identify some actions for you to follow up with after these webinars. So for the first exercise, again, just list the activities, livestock, land use change, or land uses and aggregate sources. You've got the checklist in the workbook as well. So livestock and land use categories. And then, yes, list them and identify them. So for now, we're going to do an exercise, again, opening up your workbook in that table 2. So early on for IPPU, we looked at that table 1, that top table under module F. We're now going to move to table 2 under module F, which looks at livestock. And again, where you've got a list of livestock and a number of animals, and then what I'd like you to do is find the emission factors for those animals, and then calculate total emissions for both enteric fermentation and for manure management, convert them into CO2 equivalent, and add them up together. So again, we're moving into module F in the workbook, the second table, as I mentioned. We're going to use BER 3 report. So this is BER 3, and it gives us the emission factors per head per year. So in terms of kilograms of methane per head per year, and kilograms of N2O per head per year, and we have emission factors for in the white row for enteric fermentation, and in the blue row for manure management. So what I'd like you to do is to look at your workbook, look at the animals that I've identified and listed in that table, the quantity, then copy the emission factor across, convert the emission factor, and then calculate, so copy the emission factor, convert emissions into methane and nitrous oxide, and then add them up together and convert them into CO2 equivalents. So this is the table that you'll be needing And again, that's in your slide deck, but also in the separate handout. So you want to break now for 15 minutes until 10 past and give you a chance to complete this exercise. So you've got in your workbook, you've got the animals, you've got the number of animals. You need to copy the emission factors in the green columns, then calculate total emissions in terms of kilograms of methane and kilograms of nitrous oxide, and then convert them into CO2 equivalents, add them together, and you'll get a total figure at the end. So if you can all start doing that now, and I'll rejoin again at 15 past. Any questions in the meantime, use the chat box or just speak up, and I'm happy to provide some further clarification. Okay, any questions on the exercise? No, in that case, I'll leave this slide up so you've got the emission factors in front of you as well. But good luck with the exercise. And once you've finished, if you can add in your total figure at the end, since we're all doing the same exercise, we're not scaling, everyone should get the same answer. So once you finish, if you can please add in your results, your final answer at the end, that'll be great. But I'm here for any questions. But in the meantime, please start with the exercise. And just picking up on the chat, the emission factors in berth 3 are in kilograms of methane per head per year. Even at the top, you've got kilograms of terajoules. There's a separate, and that's basically what they use for all the tables. This is a subtable as part of a much bigger table. But all those emission factors are in kilograms of methane per head per year. So there's no need to convert between kilograms and terajoules. It's all already in kilograms per head per year.
Hi, Michael. Hannah here from Iskandar.
Hi there.
I'm just curious. Under AFOLU, there's agriculture sector. For us down south in Peninsular Malaysia, we actually have a lot of aquaculture. It can be in the form of ponds or cages. So my question will be, how does this is taken into account other than the land use change from mangrove into ponds? What about those activities on water bodies? Should we just count it as like waterborne activities for the boats, things like that?
So a few things. Definitely, yeah, there's definitely a change in land use. You know, if it becomes more sort of agriculture and managed land, then definitely consider that. In terms of waterborne activities, that would only relate to transportation. So to boats coming and going if they're using you know, fuel as part of those boat trips. But otherwise, you know, in terms of the aggregate sources, and again, I'm no expert in aquaculture, I'm afraid, but definitely talk to some experts and understand what are the emission changes happening as part of aquaculture in terms of is there any additional sequestration into the ocean because of the aquaculture activities, or conversely, is there any additional release because of lighting or heating that maybe might release some further gases into the atmosphere. So I would definitely, as one of your actions, is to speak to an aquaculture specialist, speak to the industry, or speak to a university or someone who knows a lot more about it to understand, is there a big flux in emissions resulting from aquaculture activities? If there is, then you'll need to measure that, but also determine if that water body is within your city boundary or if it's just outside your city boundary. If it's within your city boundary, as you're suggesting, then it would definitely make sense for you to consider that as an activity. I would say probably more from I think more emissions are more likely to happen because of the activity rather than any sort of land use change. But definitely, yeah, sort of consider the scope of the activities and speak to an expert to understand the flux in emissions and the activities happening there, and whether either the feedstocks or the use of energy and light is actually having an impact upon the emissions coming out of the ocean there.
Okay, thank you. And there's another thing, because the change of water body into land because we have coastal area and we have reclamation areas. So yeah, I'm not sure how those is taken into account, because sometimes we have like seagrass as blue carbon sinks along the coastline. So that might have some impact. So yeah, I think we need to look into it.
I think so, yeah, and definitely, and blue carbon sinks are important, but they can also be degraded by a change in land use, or if like you're saying, if you're enclosing some of that water use into a land use, that will have an impact of also and maybe it turns from a sink to a source of emissions. But I think you've done the right thing. You've recognised that as a potential source, as a big industry, big activity, and it could have an impact on your emissions. And the next step would be to speak to an expert and understand what are the emission changes happening, both in changing land use, so from one use to another, but also during the annual use of that land. Are there any activities that result in further emissions through the use of feedstocks or through the use of other activities that have a net impact upon that emissions balance? But it sounds like it's fairly significant, both in terms of land use change and in terms of the activities. So definitely speak to an expert to understand, if even though the activity is significant, does this also have a big impact upon either additional sinks or additional sources of greenhouse gas emissions?
Okay, thank you, Michael.
Okay, we're coming up to 10 past. So just checking to see if everyone's completed their exercise. If you have, you can actually get some results in the chat box, just to see, whether you're getting similar results or some different results. So for those of you who finished, if you can just share your total figure in the chat box, that will be much appreciated. It seems like you're all very shy today. Again, I'm not going to force you to share your results, but do include them in your workbook, and I can check them afterwards. We have the first results from Deep. Thank you. 27 tons of CO2. Thank you. Any other offers, answers, similar results? Similar result using a different AR again. So it looks like everyone's getting the same kind of result, around between 25 and 30 tons of CO2. So again, not that significant compared to your total inventory, but still a sizable source of emissions. But again, I've given you a fairly small stock of animals. But again, this is the way you would calculate those emissions. Again, don't be put off by its land use. It's complicated. It can be very simple as long as you bring it down to, as long as you make the calculation simple. And yes, there are assumptions in here. You're using a broad emission factor, but you're basing it upon national data, and you should be able to estimate your stock within your city through various data sources. And Deep, you're correct. Yes, to convert that to million tons, you'd want to divide by million. But MT is also metric tons, so that's often the confusion. So million tons, the way I would use it is MT CO2e, but that's different to metric tons, which you tend to tons tends to be metric tons anyway. So the M would be is a million. So the answer is in the order of 25 to 30 tons. You divide that by a million to get a million tons, which tends to be the order of most inventories anyway. We talk about million tons for a city emissions. Just well spotted, Deep. The million should be only applied when you divide the tons by million and not to metric tons. Okay, so I'll for those who haven't shared the results, you've got the right answer here anyway on the screen, so you can just calibrate your results and check for yourself. But if not, then I'll be happy to review your results in your workbook as well. But just to know, a folio is a complicated sector, but it doesn't have to be. Depending on if you're willing to make some broad assumptions and you've got good emission factor data, then it can be fairly straightforward. Okay, so that was the exercise, so well done. So again, final tasks for you is to complete table 3 and table 4 on sort of next steps. Again, table 3 is this table. We've just done 5.2, so you can record that 2730 tons in scope 1 there. Sorry, in 5.1 on the livestock. We've not done land, so put in not estimated. Same for aggregate sources, not estimated, and same for scope 3. And because it's basic plus, we don't have to estimate them, so we can use the notation key not estimated. And an action plan is for you to define additional actions you would like to take, and who would take those actions within your city authority. Okay, any final questions on a FOLU or on the homework or the exercise, the calculation? Okay, I just want to make one final point. I noticed, having gone through going through the previous homework, that most of you didn't quite fill out table 3, which is the GPC summary table. This is automatically done for you in Cirrus, but it's important to understand how it is compiled. So all you would do is you would put the data you've calculated using the exercises, put them in the right box, and for everything else you would apply a notation key. Either not occurring if the assumption has been the activity doesn't take place, and we can use that for basic sources. For basic plus, I would always put not estimated, unless you're very sure those activities don't occur, but you can use not estimated for scope for basic plus sources. Then there are 2 further columns in your workbook under table 3. I'm just opening it up for myself. One asks you for the methodology that you've taken, the calculation, and that could just be a very simple sentence. And we discussed this in one of the earlier sessions. It could just be based on scaling national data, based on scaling other city data, based on activity data multiplied by IPPU emission factor. So just a 1 line, a very simple bullet, just to indicate what assumption you've made in calculating those emissions. But it just adds transparency to the process. Again, the question that came up earlier, just always be open around your assumptions, your methodologies, and what you've done to calculate those emissions. And then the final column on data sources, just add in Berth 3, IPCC, NEB, made up data, whatever. Just indicate a source of the data. And it's good practice to start doing that now. So you always document your methodology and you document your data source. So if you haven't done so yet, please can you make sure you complete table 3. We've now done all the sectors. So you have all the data you need. And where you don't have data, you would use a notation key, either NO, IE, or NE for not estimated. So please do populate table 3 with either data from the exercises in the right subsector in the right scope, or use a notation key. And again, in the notes that I've shared with you, the handouts, I've taken you step by step through which boxes to populate. So if you're a bit unsure, then please go back through the notes and you should have all that information to hand. Okay, so we'll use the last 10 minutes of today to talk about other scope 3 emissions. And these are emissions that take place because of activity in your city, but that happen outside your city and aren't yet covered by the GPC. So for example, if I buy a television and then the energy used in using the television, the electricity will be counted as scope 2 under 1.1.2. But if the television is made outside of Malaysia, say in Indonesia or in China, those emissions aren't captured in my inventory. And that's fine because you don't control those emissions. They're, the processes are controlled by Indonesia's government and the Chinese government and their standards, etc. But those emissions are driven by me because I'm buying a television, I'm creating that demand. Those processes and those resource extractions happen because of me. And therefore, some argue that those emissions would be useful to capture in your inventory because they're emissions driven by consumption in your city. Those emissions wouldn't have occurred if you didn't want to buy a television. And if your residents in a city are wealthier, if they consume more, if you encourage them to consume by building big shopping malls, etc., or by reducing taxes on products, then that is something you could seek to influence as a city authority, for example. But the argument here is often that the basic and basic plus emissions focus very much on activities taking place in a city, but often there are activities taking place outside a city that are driven by your city that result in huge emissions through a supply chain serving the city. So this graph, which you remember from the first week, shows the full inventory boundary and city boundary. So the city boundary is shown in grey. That's everything that happens within a city. Those are scope 1 emissions. The inventory boundary shows additional emissions that take place outside your city, but are driven by activities inside your city. Now we've covered those for waste, where we send waste outside the city to be disposed, and we report them as scope 3. We've also covered them as part of transportation, where people from the city drive or take a train outside the city, and we capture those both as scope 1 in boundary and scope 3 out of boundary emissions. We've also looked at those for stationary energy, where we're using electricity, and we have these big transmission networks, these big pylons that carry power from outside the city into the city, and they lose some energy on the way. That's also a scope 3 emission source. We also have this other category, which is everything else that supplies the city and is part of what really makes a city function. And this is food, this is retail products, this is other activities, tourism as well by city residents. So it captures everything else. It's not part of basic or basic plus, but it's something you might want to look into as a city authority to think about, actually, what are my additional emissions beyond basic and basic plus. There's a really useful diagram here, which is based upon a C40 study that we did a few years ago, where we looked at the GPC emissions for all our cities, and we looked at the other scope 3 emissions from our cities as well. And the purple circle are all the GPC emissions, and the green circle are all the consumption emissions from everything the city does, but those emissions take place outside the city. And you can see that that's much bigger than the GPC emissions, and that is because most cities are fairly small and fairly compact, and they rely on a huge supply chain to make televisions, but also to make refrigerators, to make building materials, to produce the food that come from outside the city that currently aren't captured in the basic or basic plus inventory. So if you'd like more information on this, there are 3 really useful reports to have a look at. There's a standard called PAS 2070, which is similar to the GPC, but it goes beyond the GPC, and it also looks at scope 3 emission sources as a standard. It's quite a dry document, so if that puts you off, then don't read that. But if you like the detail, then definitely have a look at that report. The better report is called Application of PAS 2070 to London, which is a case study applying PAS 2070 to the City of London, and it really looks at what all their emissions are, both from a GPC perspective, but also from a consumption perspective. And actually, they conclude that for London, their GPC emissions are around 45 tons of CO2, million tons of CO2 per year. Using a full consumption approach, it's a 120 million tons per year. So a 3-fold increase in emissions by looking at the full supply chain, which includes aviation, which includes all the food imported into the city, but also all the consumer products, the clothing, the electronics being shipped in from other countries. So have a look at that report, because it's very useful to understand what it means for an individual city to look at a consumption approach as well. The third report is the C40 report, where we looked at all C40 cities and estimated their consumption emissions and compared them against their GPC emissions. It gives some very interesting conclusions and looks at the big supply chains supporting cities. So again, this is an optional sector. It is much more complicated. It's often more difficult for cities to really control those emissions because they take place outside the city. Therefore, they're much more difficult to control. They're often part of long, complicated, complex international supply chains, which makes them very difficult to measure. But something for you to be aware of, certainly as an infantry compiler, it's useful to know more about this, even if your city isn't going to measure them. And again, for now, I would focus on basic. When you're starting out, just focus on basic, then maybe basic plus, and maybe in a few years' time, think about additional scope 3 sources. But for now, it's very useful to be aware of what these sources are. And so, so at least you can talk about them when you're being asked questions on them. So that's scope 3 emissions. Let me just pause there to see if there's any questions on scope 3 emission sources. Okay, no questions. Again, just to repeat, this is not required. This is not even recommended. This goes beyond basic plus. It is there for you if you'd like to know more information around scope 3 sources, what they mean, how they're calculated, and maybe start thinking around, well, does it make sense for your city to do something like this in a few years' time? Focus on basic now, maybe basic plus if that's relevant. This is more just background information to get the bigger picture. But if you have the time and the interest, I would definitely recommend reading those last two reports, application of PAS 2070 and the C40 consumption-based emissions report. They're both very useful and give you a much bigger picture of the issue around Scope 3 emission sources. Okay, well, that then completes our session today. Again, a quick summary. We covered IPPU and a FOLU, both theory for IPPU, and then we did a practical exercise on scaling national data for product uses. And we assumed, certainly for the exercise purpose, that there were no processes taking place within our city for now. For a FOLU, we went through the three subsectors: livestock, land use and land use change, and aggregate sources, so particularly the fertilizer application, burning of biomass, etc. And we then did a practical exercise estimating emissions from livestock based upon a sample of animals and using the emission factors from birth 3. And then finally, I just quickly covered other Scope 3 emissions to just give an example of what that could mean and where to find more information on other Scope 3 emissions. So that then completes today's session. Just a reminder, before we finish, and as part of your homework, please do make sure you complete Table 3 in your workbook, because that is the GHG summary table. So do copy across the data from your calculations into Table 3 and use notation keys where you don't have data, NE for basic plus sources and NO for those basic sources we didn't estimate and we assumed weren't occurring. So please do make sure you complete this, especially before next week's session, because next week we're going to go dive into cirrus, and we're going to start applying cirrus. It's very important that you understand this table and you have a completed table before we start that exercise. So with that, I'm going to close my my slide deck, and I'll be open for any further questions. So let me just pause there, see if there's any further questions on the content today, or maybe even on the session next week. Okay, and if there are no further questions, then Deep's shared with you the survey form for this week. So if you can all please maybe use these last few minutes to complete the survey. Again, that helps us to make sure that we're building on your feedback and we're running the session the way you would like us to. So do tell us if there's anything else you would like to cover over in the last 2 weeks. We've got 2 sessions left, sorry, 2 sessions next week. We're going to go through cirrus next week on Monday, and then long-term inventory management on Wednesday next week. If there's anything else you'd like me to cover in addition or to cover again, please let me know, and I can make sure we can find time to cover those additional items as well. So with that, thank you very much for joining today. Please do complete the survey. Please do complete the exercises if you haven't done so yet. And please complete Table 3 in the workbook before next week's session. So back over to you, Deep.
Thank you, Michael. So this concludes the Module 6 of our training. And basically, we have covered all the sectors that's required for inventory development. Next Monday, we will look into series, right? That's the spreadsheet that we used the last session. And yeah, please fill in the survey form, and also please complete your homework, all right? Try to do as much as you can during this week, and submit, and you can email to me, and I'll forward it to Michael for his review. Yeah, so we have 2 sessions left next week, next Monday and Wednesday, and that will conclude the training. So thank you, everyone, for your time. All right, I know everyone's busy schedule, so once again, appreciate your commitment and participation in this workshop. All right, with that, thank you, and have a pleasant evening. Bye, everyone.
Thank you very much.
Thank you. Have a good week.